13.7 billion years ago, an explosion created the time and space we live in. The Big Bang was the beginning, and I believe it's reasonable to seek answers about how it will all end, as we humans tend to be a bit interested in apocalypses. Let's get one thing perfectly clear. You can't outrun this ending, only if you were a particle. I'll skip right to the point of why the universe will reach climax. We don't have eternity. The current state of matter in the universe is like this. 5% is normal matter, including planets, stars, galaxies, and also me and you. Weird that we even call it normal matter. 26% is dark matter, which we can't detect for now. But what is in our interest is the remaining 69%. That is left for dark energy. Why is it important? Dark energy is doing something fairly opposite of what you would expect dark things to do. It accelerates the rate of expansion of our universe, and fast. That means it's good, right? Not so much. And the best part is, if the universe's opposite gravity contraction can't stop it, and that is very possible, the universe will expand forever and die in the meantime. Big freeze, or heat death, or eternal sub-zero expansion, as I call it, will drain the universe of all its colors and leave it cold, dark, empty, and dead. If you've stayed with me this far, you are serious about knowing more, so here's how it will all happen. Presently, and for around the upcoming 100 trillion years, the universe will be in its most glorious Stelliferous Era. If you could guess it from the name, it will be an era full of light and warmth. With galaxies, stars, and planets coming to life, the universe could never be more bustling. However, our cosmos bursts larger with every passing minute. I hope you didn't forget the dark energy. But the amount of matter within the universe remains fixed, and so all that matter slowly spreads out over more and more volume. After a while, cosmic dust won't be dense enough to forge clusters of stars and galaxies anymore. Thus, in around 100 trillion years from now, the last star will be born. Consider subscribing now. I wouldn't want you to miss out on any video. Let's pause for a moment and discuss time before we hit the trail with the next tragic phase. Why time is important here? Think about it. Without time, there is no structure, no system, and we would be counting days to get by. Simply put, it plays the role of a compass for every event in the universe. Going back to our case, scientists were able to predict phases of the Big Freeze by observing what happens as time passes and the universe expands. When you know all sides of the rectangle, the area is easy to calculate. But there's more. The arrow of time is flowing from present to the future. Don't be mistaken. At the end of the Stelliferous Era, time is still moving forward, and it won't stop for quite some time, which I can't even pronounce. Well, not for now. However, when time becomes significant, that's when we should start worrying. What I've noticed is that time is meaningful when you have someone to observe and measure it, like us humans. Going back to eternal sub-zero expansion, or Big Freeze, or call it what you wish, time is slowly losing its significance. The next phase is called the Degenerate Era. Here, it turns interesting. You'll like it, or you won't. It will last until the degenerate remnants finally decay. That's something like 10 duodecillion years. Small red dwarfs will become brown dwarfs, and stars more massive will decay to white dwarfs, neutron stars, and black holes, making them the only stellar bodies to ever exist. The universe will become extremely dark, with occasional light coming from white dwarfs and neutron stars. Out of that unimaginable time, even white dwarfs and neutron stars will perish, leaving just black holes and black dwarfs. But there's more. Black and brown dwarfs will too radiate away over immense timescales. Black holes will stick around for some time though. If you think there's some reverse way of matter going back to the loop, then you're going to hate me for saying this. From what remains, I don't see any way how matter will turn back to cosmic dust, enabling new galaxies to form. And don't forget, the universe is still expanding, making it even harder for matter to cluster back together. The exciting news for you is that you probably won't be around anymore. With zero light and warmth, life wouldn't be too enjoyable. The universe hasn't got anything to offer anymore, even if we manage to colonize the Milky Way and galaxies beyond. Thus, time will become questionable if there is no one to count it. If there are even some aliens out there, then they would be presumably long gone too. However, I think that time is still significant. When the Big Bang created the universe, clocks started ticking. Well, not literally, but we assign the Big Bang to a specific time in the past. We can all agree on one thing. Before life on Earth evolved to humans, time was still passing in the universe, and it doesn't matter if we were around to measure it. By the year 10 trillion, there won't be anything but black holes left. So the third phase is respectively called the Black Hole Era. Black holes will be the only normal matter left. If you could somehow witness this phase, then I'm sorry to tell you that day doesn't exist anymore. Only night for you. Well, at least no one will be around to see. Have you ever wondered what will happen to black holes? Eventually, even black holes will disappear as they slowly give off radiation until they eventually evaporate. What will the universe be like after the black hole era? What will be left of normal matter? All of your answers are hidden in the dark era. The universe will consist of only a sea of electrons, positrons, neutrinos, radiation, and potentially dark matter, which is still a little understood substance that does not absorb, emit, or reflect electromagnetic radiation and may not decay at all, being in the universe for eternity. Whatever remains, however, will be very spread out. That's because the universe will likely continue to expand. I can't precisely tell you how far things will be spread out, but some physicists say that even in the scale of our observable universe, there could be just a small number of particles. What can I say about time in the last phase? From the dark era, it will bear no significance whatsoever. You might think that time doesn't exist in this phase at all. Let me explain. If you ask me, time would still pass by. Because even after all matter is dissolved, it should still be present in the universe, although not in standard form. What many scientists say is that time is not relevant after we perish, which is true for us, but it still flows in the universe. We can't declare that it stopped or doesn't exist. The point is that everything in the universe is particles, dark matter, and dark energy, with zero living, shining, or warm matter. Time loses its meaning. It doesn't serve anyone. By the way, this is just my educated guess about time, but I'd love to hear your thoughts. If you still wonder whether the universe can reboot itself, then I would say, I don't know, and it is not likely to happen. No mechanism or event is known to do that. What you would need to do for the reboot is to gather all present energy and make it somehow useful. But all systems are already in the ground state. There's no longer any way to do that work. Doing that work would require you to have a useful reservoir of energy, such as a battery or a system that is not at its ground state from which energy can be extracted. In the Big Freeze scenario, no such systems are remaining. Before the Big Freeze, there will be many events and discoveries happening, including solving the question of what is beyond the universe.